Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afzan Hamizan bin Abdul Rahman. Today I will present about the general information of our fleet, that is Buffalo Fleet Australia. So to begin with, I will continue with the location of the Buffalo Oil Fleet. So Buffalo Oil Fleet is located under production license WA19L and WA21L, part of the previous WA260 permits in northern Park Basin, roughly 300 km off the coast of northern Western Australia and about 9 km to the southeast of La Maria Oil Fleet. As you can see in the picture, the location of the Buffalo Oil is on the sea floor, which is between the East Timor and Northern Territory of Australia. So to go there, we need to have intermediate transport such as helicopter or ships. So next is Buffalo Oil Fleet story. Buffalo Oil Fleet was discovered by an oil and gas company named BHP Petroleum in 1996. BHP Petro Priority Limited discovered the field in late 1996 and announced in September 1998 that the field would be developed. The production license was granted in September 1999, with the first oil production commencing in December 1999. The discovery of oil field has led to the first drilled oil well in the area, named Buffalo 1, striking a 45 mm oil column in good quality iron formation sandstones at about 3,270 mm subsea. A 27 mm interval where production tested, giving 52.7 API oil at a stable rate of 16,720 barrels per day. Buffalo 2 dug in was in May 1997 with a 2.65 km to the east of Buffalo 1, proof that the oil contains into the eastern half of the structure. The Buffalo Oil Fleet was expected gross capital cost is 150 million US dollars. So for the discovery method of the Buffalo Fleet is, first, the Buffalo Oil Fleet was discovered following a conventional seismic survey, which detected the structural element of entrapment, stratigraphic changes, controlling and accumulation, which are known from the subsurface geology, were not recognizable from geological data. So, a 355 km 3D seismic survey over northern west 260p was obtained, and WE processed from March 1996 to January 1997. Multiple animation and signal to noise ratio assessment were also prioritized. So as you can see in the static update 3D update range data, you can see the picture show that wave equation determining WED in representing existing 2D data of Buffalo. The difference between the two sections is quite remarkable. On the WE section, shallow, deep, even below Big Bang are inserted. The remaining real faults are sharp and thinning of the shallow section below the bank, possibly caused by carbonate bank loading, and revealed WED has also removed the push down below the seafloor channel to the south of Big Bang in order to make assured that the well is accumulated with the oil. So then the adjacent picture, which is WA, as recognized with the 3D data, also got an intention because by using that, the standard residual static of the WED can reduce the problem caused by the inaccuracy in model. So the picture shows that the residual static applied to the Buffalo data, most of the model up to 200 mm per second were around the margin of the carbonate band were imaging of the water bottom was less accurate. So to continue, I will continue with the exploration production company. The exploration and production companies that currently operating in the Buffalo oil field is the Australia company named Carnarvon Energy. Carnarvon Energy Company also a pioneer in thought innovation, bold investment in the latest data and technology, making discoveries many thought not possible. Mostly the company unlocking the largest oil field in Western Northwest South, and mostly this company unlocking the largest oil field in Northwest South. Okay. So I will continue also with the cumulative production to date and estimate mineral reserves. Buffalo Flat production started into the Buffalo Venture FPSO in December 1999 at the rate of 40,000 BOPD barrel per day from the Tau production well. The field produced for 5 years with no material decrease in reservoir pressure. Initial production from the first two initial production from the first two wells produced in excess of the 40,000 barrel per day design capacity of the processing facilities. The exploration phase of the Buffalo PSC expired 26 May 2023 following a one-year extension granted by the Carnarvon Petroleum Timor. This production also may be followed by an exploration extension for 25-20 development and production period. Buffalo oil field has estimated oil in place with the range of 115 million barrels of oil. So as you can see, this is the oil originally in place or OIP, and the mean of the oil is 115, and the present price of oil and gas which is $108.61 as June 22. The total value reserve present of oil for the Buffalo oil can be calculated by multiplying the oil in place in barrel by the current oil price per barrel. So we can multiply 155 with the million reservoir barrels, which is OIP of our oil fleet. So 108.61 is the current of the oil price for nowadays. So we multiply and we got 14,000 million US dollars. So this so meaning that this revenue price for the oil and gas production. So that's all from me. Thank you.
My name is Farhan, and now I'm going to briefing about the second point, regional tectonic setting. So in this part, there are three subparts, which is basin type, basin age, and also sedimentary field. So for the first part, basin type, the Bonaparte Basin is a French-shaped hydrocarbon bearing basin. During the Devonian to early Carboniferous period, the basin developed a V-shaped type of basin with a north opening rift. Initial rifting occurred in the late Devonian and was symmetrically overpinned in the late Carboniferous to early Permian by northeast trending rift basin. Next, for the basin age, Bonaparte Basin age is related to the type of basin and relate to the stratigraphy of the offshore Bonaparte Basin. Sediment present in the offshore Bonaparte Basin range from Cambrian to Holocene, and for the ages are arranged as late Devonian, Carboniferous, Permian, Triassic, Jurassic, Cretaceous, and Cenozoic. So for Cambrian to Ordovician, this is the first stage how the basin age from Cambrian to Ordovician. At this stage, seismic section in the offshore part of the basin are the reason for the cleavage being able to be identified, but the Cambrian sequence is exposed onshore with a state of intratectonic deposition and predominantly siliclastic. At this stage, margin deposition is shallow and will continue into early Ordovician. Next, for the Cretaceous, the first thing happened in the Buttress Island group make up the bulk of the post-breakup stage sediment in Petrosac Basin. The thickness here is able to reach 2,000 meters. In Albion, marine siltstone and claystone are present on the start block, and as an ending, a carbonate marine shaft was established over Western Ashford platform. Okay, next, the last part is basin sedimentary field. So here is the table of age, location, and thickness. So for the first age, Carboniferous, at Point Spring Sandstone, the thickness there is between 187 until 385 meter. For latest Carboniferous, at Fossil Head Formation, the sediment there is 590 meter thickness. Latest Permian, at London Dairy Height, between 670 meter. Late Jurassic, Sandpiper Sandstone 500 meter. Cretaceous, at Petrel Subbasin, between 2000 meter thick. Paleocene, South Bonaparte Basin, between 1300 meter. And the last one, Mid-Miocene, at Ashmore platform, the thickness is between 400 meter until 1000 meter. So that's all.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So my name is Ali Zakri bin Roslan. My metric number is TH2046, and I'm going to present about petroleum system elements in Buffalo Field, Australia. So what is a petroleum element? So the petroleum element consists of a mature source, rock, migration pathway, reservoir, and trap and soil. So appropriate relative timing of the formation of these elements and the processes of generation, migration, and accumulation are necessary for hydrocarbon to accumulate and be preserved. And exploration plays and prospect are often established and in a basin of or region where there is a reasonable chance of finding any comprehensive petroleum system. So for the first element, which is source rock, so source rock are the rock that contains sufficient organic material to create hydrocarbon when subjected to heat and pressure over time. So many wells drilled in a Balkan subbasin have encountered late Jurassic oil prone marine source rock, which is a Balkan formation. So many of the petroleum accumulation found in the region appear to have been sourced by source rock facies within the Balkan formation, with which appear to be sufficiently thermally matured. So following this interpretation, Edward, we found that the claystone from the Upper Jurassic Lower Balkan Formation had been geochemically tied to several of the oil found in the Balkan subbasin. So the Equatorial Formation, which is provide a regional seam to the underlying Upper Balkan Formation reservoir, also has substantial source rock potential, although it's likely thermally immature to marginally immature for the petroleum production throughout much of the Balkan subbasin. So next we go to the seal rock. So what is seal rock? Seal rock is a permeable rock, commonly shale and hydrate or salt, that form a barrier or cap above the around reservoir rock, such as fluid that cannot migrate beyond the reservoir. So the seal rock is a critical component of the completely petroleum system. So in our region, which is Buffalo Field, the seal rock is begin with the regional flooding of the northwest continental margin in the Varangian lead to the deposition of the Cretaceous Beaches Island group. So the lower Cretaceous shale of the Equatorial Formation were deposited at this time and formed a regional seal across the subbasin. And then the trap integrity and several Jurassic or Triassic reservoir tilted fault block in the Balkan subbasin rely on the adequate infrared formational and cross-fault sealing. So this is the figure that generalized stratigraphy of the Bonaparte basins. So next we go to the reservoir. So reservoir is a type of the rock that allow oil to be trapped in the porous medium. So pores and thrown in the reservoir rock create a flow channel and accumulating system for hydrocarbon, as well as the sealing mechanism that prevent hydrocarbon penetration into the surface layer. So in Bonaparte Basin, we can see that the bulk of the petroleum accumulation in the Balkan subbasin has been discovered in clastic unit within a pre-extension and a reef phase. So in the middle Jurassic flower formation are two reservoirs. They have a two reservoir which is from commercial production, and then which commercial petroleum production, which is at Squat and Jabiru. So the main exploration target in Balkan Subbasin are fluvial-deltic fan of the Middle Jurassic Prober Formation and the Upper Jurassic fan deltas of the Montara Formation, submarine fans of Balkan, and then Laterastic, Calis and Norm Formation sandstone and Upper Cretaceous Puffin Formation sands. So lastly, the overburden rocks. So, overburden rock is a sedimentary rock above the overburden, compress and consolidate the material below. So, because of the high temperature of the great depth, at the great depth, the overburden rock overlies the source rock in the petroleum system and contribute to its thermal maturation. So, in a buffalo feed, it has a high thickness of the overburden rock because of the combination of the fluvial delta and delta sedimentary resultant. So the age and thickness of the overburden rock determine the dwell rate and the turbidy influence the heating rate. So that's all from me. Thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh. Very good morning. Okay, so my name is Muhammad Aiman bin Abdul Rahman. My ID is TH20055, and today I will be presenting about 3.0 petroleum system process in Buffalo Field, Australia. So let's go. So first of all, what is meant by petroleum system process is that petroleum system process is a petroleum system that include all genetically connected oil and gas accumulation as well as a pot of active source rock. It encompasses all of the geologic ingredients and process that are required for the formation of an oil and gas accumulation. Petroleum system process can be divided into two processes, which are trap formation and generation, migration, expulsion, and accumulation. So, left here is the contour interval of the buffalo field. So, for the next is that for the trap formation. So, for the trap formation, it involves the underground that blocks the movement of petroleum, causing it to concentrate in a reservoir that can be extracted. So, the petroleum cannot escape upward or laterally because of a layer of impermeable rock called cap rock. So, an anticline, a structure with an concave as viewed from the below roof created by the local deformation of the reservoir rock and the impermeable cap rock, is the most common type of a structural trap. The reservoir borders are determined by the intersection of the oil contact with the cap rock. So, as you can see right here, is the plot history of the buffalo field. So, as we can see, it starts from the tertiary and then Highland Bay, Fossil Head, Killings, Tertiary, and so much more. Okay, so it is necessary for hydrocarbon to accumulate and be preserved. The buffalo field is produced from a structural stratigraphic trap formed by a combination of faulting and truncation, and the field consists of a stratigraphy structural trap with a southern dip that is monoclinal as well as a strike slip. Is generated as a result of tectonic, diaperic, gravitational, and compactional process altering the subsurface structure. So, for the last part is that the generation, migration, expulsion, and accumulation. So, when the oil and gas is stuck under the generation, after the generation, Migration is the process of transporting it from the source rock to the reservoir pores. So compression, buoyancy, chemical potential, thermal expansion, topography, measure, me- maturation, volume increase over time, and gravitational separation of hydrocarbon and water are the key factor in oil and gas migration. The process of hydrocarbon from the petroleum source rock into the carrier bed or migration conduit is referred to as expulsion. So right here, as you can see, is the geological structure. This is the generation, and then number two and number three is the migration, and then number four we go to the accumulation. Okay, compaction, chemical reactions, source richness, corrosion type, and thermal expansion are all elements that contribute to the expulsion event. Hydrocarbon accumulation forms when migrating hydrocarbons filament encounter a zone, the seal, either laterally or vertically with pore throat size smaller than the carrier bed. Okay, that's all for me for the petroleum system process. Thank you very much.
So for the conclusion, the basin of Buffalo Field, Australia, has a contingent resource of 2C around 334.3 million barrels of oil. Bonaparte Basin has high quality oil with 53-degree API oil including free contaminants such as sulfur. Even though the amount recovery oil has been quantified in 1C to 3C, there still remains a 10 probability of outcome that is worse than 1C. Unfortunately, appraisal in January 2022, one of the sub-basin there showed that the appraisal outcome is worse than 1C, which means that the oil there is not worth commercializing. One way to prevent this event from being repeated in the future is to enhance oil recovery. Enhanced oil recovery is used to improve oil production from a well. Water flooding and carbon dioxide flooding are some of the type of system. By injecting water or carbon dioxide into oil well, the recovery system will improve since both of the elements are miscible to oil. In addition, carbon dioxide mobility will be lower, then making the gas can effectively displace the oil wells. Thank you.